In this problem, we are given the mathematical expression of a system and we are asked to determine its properties. The first property we examine is whether the system is memoryless or with memory. A system is memoryless if the output at any time depends only on the input at that same time. If we look at the given system, the output is defined at time n, but the input appears at n plus 3. This means the output at time n depends on the input at a different time instant. For example, if the output is evaluated at n equals 1, the input is evaluated at time 4. Since the output doesn't depend only on the input at the same time instant, the system is not memoryless, therefore the system is with memory. The next property we examine is whether the system is causal or non-causal. According to the definition, a system is causal if the output at any time depends only on the input up to that time, meaning present or past values. If you look at this system, the output at time n depends on the input at n plus 3, which is a future value. So, the output at time n depends on the input 3 time units in the future. Therefore, the system is non-causal and it is a non-causal system. So up to now, we have determined two properties. The system is with memory and it is non-causal. Now we move to the next property, which is linearity or non-linearity. To determine whether the system is linear or not, we proceed as follows. First, we replace xn with a specific input, say x1n, and we call the output y1n. This becomes n minus 1 multiplied by sine of 2x1n plus 3 plus 4. Next, we replace xn with another input, say x2n, and we call the output y2n. This becomes n minus 1 multiplied by sine of 2x2 n plus 3 plus 4. In the next step, we replace xn with a x1n plus b x2n, and we call the output y3n. To obtain y3n, wherever we see xn, we replace it with a x1n plus b x2n. If xn plus 3 appears, then only n changes accordingly. So y3n becomes n minus 1 multiplied by sine of 2a x1 n plus 2 b x2n plus 4. Next, we form a y1n plus b y2n. This becomes a n minus 1 multiplied by sine of 2x1n plus 3 plus 4 plus b n minus 1 multiplied by sine of 2x2n plus 3 plus 4. Now, to determine whether the system is linear, we compare y3n with a y1n plus b y2n. If they are equal, the system is linear. If they are not equal, the system is nonlinear. When you compare them, you see they are not equal. Therefore, the system is nonlinear. The next property is to determine whether the system is time invariant or time variant. For this, we proceed as follows. First, we apply input x1n and obtain y1n as shown. Then we apply input x2n and obtain y2n as shown. Then we replace x2n with x1 and minus n0. And we call the new output y3n. This becomes n minus 1 multiplied by sine of 2x1 n minus n0 plus 3 plus 4. Next, we form y1 and minus n0. This becomes n minus n0 minus 1 multiplied by sine of 2x1 and minus n0 plus 3 plus 4. Now if y3n equals y1 and minus n0, then the system is time invariant. If they are not equal, the system is time varying. If you look carefully, n minus 1 is not equal to n minus n0 minus 1. Therefore, they are not equal and the system is time variant or TV. The next property is stability. We use BIBO stability. The system is stable if every bounded input produces a bounded output. To test this, we assume a bounded input, for example, a constant value a. Then the output becomes n minus 1 multiplied by sine of 2a plus 4. Now we check whether the output can become unbounded. If n goes to infinity, the output also goes to infinity. Therefore, the system is unstable. Some students ask, you said the input must be bounded, so why did you let n go to infinity? The answer is that n is not the input. N is the independent variable and we can take any value. Therefore, the system is unstable. The final property is invertibility. A system is invertible if different inputs produce different outputs. To check this, we test two different inputs. First, we let xn plus 3 be 0. Then the output becomes n minus 1 multiplied by sine of 4. Second, we let xn plus 3 be 2p. Then the output becomes n minus 1 multiplied by sine of 2p plus 4. We know that sine of alpha is equal to sine of alpha plus 2p. Therefore, two different inputs produce the same output. Hence, the system is non-invertible. In this example, we examined 6 system properties: memoryless or with memory, causal or non-causal, linear or non-linear, time invariant or time variant, stable or unstable, invertible or not invertible. If you found this example useful, you can check out other solved problems on system properties available on this channel.